So for our final session today, I'd like to talk a bit about how to compile LAMMPS because it's one of those things of we've used a number of applications within LAMMPS that you might want to know or be interested in how to use. Then I also want to talk a bit about running LAMMPS through Python. But let's start with the compilation. Part of the reason that I'm talking about this is to make sure that if you are wanting to create your own version of LAMMPS, you can copy the build instructions here, and at least on Archer 2, you should be able to get exactly the same version of LAMMPS as I have so far. So I tend to build LAMPS these days. Like I used to always use make, like the LAMPS make files to build things, and then a couple of years ago, I was reading about their CMake build, and I found that actually it's just so much more easy. So what I'll do is I will switch to first time as well, and go into my work directory. To go, and if I make a directory called build lamps, I'm simply gonna, if I run the correct command, that helps. All I'm going to do now is copy paste the build instructions from the course material. You don't need to do this. It's more to give you an idea of just how easy it is to build lamps and how easy it is to change your lamps build. So the first thing I'm going to do is I am going to clone the lamps GitHub repo. And within the LAMMPS GitHub repo, I am going to create a directory called build. And that'll be my build directory. It'll be where I'm going to run CMake in order to build the build LAMPS. And now, yeah, I'm going to make a directory within the my lamps called build, and then I'm going to go to that directory. Next, this is the Archer 2 step. I'm going to load all of the modules that I need to compile LAMPS. First module I'm loading is the GNU programming environment. And what that does is that allows me to use the GNU compilers, so GCC, G++, G-Fortran, when I compile. By default, the default Archer 2 environment uses the Cray Clang compilers. I think are just Clang and I guess whatever C++, whatever the Clang C++ library is called. And I think there's also the Cray version of Fortran. I don't think they've gone to Flang yet. The other modules I'm loading are Cray Python, which is a Python library optimized by the people who provide Archer 2 as a machine, and it's optimized to run very efficiently in parallel on HPC systems, and it's excellent. Like if you can use it, I strongly recommend you do. I'm going to load the fast Fourier transform module, and also I'm going to load a more recent version of CMake because that's what I'll be using. Next, I'm going to run the CMake command, and the CMake command has a lot of information in it. What am I doing in there? The first thing I do is I'm defining the compilers. Now, LAMMPS is a bit strange insofar as the compilers have compiler wrappers. So instead of having to say using MPI C++ for my CXX compilers, my C++ compiler, I can just use the compiler wrapper uppercase CC. I'm then going to define path in which I'm going to install this. I'll need to change this because path to install, I don't have access to that directory. If I do this, ooh, that looked worse. Cool. Build MPI equals on. That means I want to build the MPI libraries. Build shared libraries, yes. This is super important if you want to run LAMMPS in Python which is what we're about to do, you need to have the shared libraries built. And one of the nice things about CMake is you just put that command in, and hey ho, you've got it. We want to use FFTW3, where this is the path to the FFTW include and libraries, lib directories, which are both needed for the compilation. And then after that, all I'm doing is I'm naming all of the LAMMPS packages that I want to build. So this specific build will have the packages aspherical, body, class 2, colloid, core shell, etc., etc. One of the ones worth noting is that there's package OpenMP, which is important if you want to run hybrid MPI and OpenMP jobs. And the other one is package Python, if you want to run Python jobs. For those of you who run on GPUs, you'll probably want to add, I tend to prefer the just straight up GPU package rather than the Cocos package. But because I find that it's likely to work and it's quite fast. As in it's fast enough that I'm happy with the speeds I'm getting. But to do that, you'd need to use the package GPU as one of the packages here. You'd need a -d pkg underscore GPU equals yes. And you'd probably also need to, you would need to link to the GPU libraries as well. So here I've got an FFTW3 library. I'd need an equivalent include in library for the CUDA libraries, supposing that this is a CUDA GPU. Okay, so I'm just going to change my path to install to the directory on up to LAMMPS install. There we go. And if I press enter, it's not happy because I need to do CMake. There we go, press install, enter. It just runs the CMake commands. And what CMake will do, and the LAMMPS CMake file is really well written. CMake is one of those weird programs where if you've got a good CMake file, it does everything brilliantly in background and you don't need to worry. And if it's a bad one, then it's more hassle than it's worth. In this case, the LAMMPS developers have spent enough time to make in my opinion, a very good CMake file. And CMake will sort of like run and look for all of the libraries. So for instance, it's looking for like, does the fopenmp flag work? And yes, it does. So yep, that's true. We found a version. Gzip works, yes. Gzip work, yes. They didn't find ffmpeg. That's fine because we don't have ffmpeg on R2. What about FFTW3? Yep, and it just goes through the list and checks all of the things. And not a ton of information. It will even tell you if you've defined some packages that it then couldn't find. It'll tell you, oh, you've asked for this and you didn't. So it's always worth looking at the log file. It's quite a quick way of seeing exactly what's going on. And quite often the error messages, definitely in again, CMake is one of those things where the error messages you get will be dependent on how good people who made your CMake files were at making the error messages. But in LAMMPS' case, they're quite easy and intuitive and easy to understand. Once I've done that, I just build by make. So before I do that, CMake has created a ton of new files in my directory, including a make file, also some log files, stuff like that. When it's all done, I just make -j. The -j and then a number command is essentially saying I want to run the make command, but parallelize it. And in this case, I'm parallelizing over 16 cores. And it just builds. Building LAMMPS. And it'll take probably about a minute, I reckon, at this speed. While it does that, let me share back to sharing the screen. So on. As you can see, I'm just literally going through the steps. If you go on the LAMMPS, in the LAMMPS manual, and just list the packages, it just gives you a nice list of what all the packages are that you can install. You'll recognize some of them. So molecules, one of the ones that we're installing, OpenMPs that we're installing, and that I highlighted, Python likewise. I mentioned really quickly the GPU package. And then for each package, it sort of tells you what it does and who created that package, which is a really nice touch. And it sort of tells you the things that it can help. And then it also gives you a list of all of the information within the LAMMPS manual that you can find that helps you tell you how to use that package. So that's really, in my opinion, very handy. There's also, if you look at the, where would it be? I guess it would be build LAMMPS. Build with CMake, build LAMMPS with Lake, packages with extra build options. If you want to build a special package, and you'll notice some of the ones we've mentioned, like GPU, yep, GPU's on there. I've not installed this because it takes a few extra steps, and also because Archer 2 doesn't have any GPUs. But it tells you this is the extra things you need to maybe consider including and what the defaults are for the packages that are a bit trickier to run. I suspect there'll be one also for Quantum Espresso. Where is Quantum Espresso? Maybe say. Anyways, and Python also. That's one of the ones. One path to your Python executable, but actually because it's already in our path when building this, we don't really need that. Cool. So by this point, I suspect that my build is complete. Let me. There we go. And once it's built, there's a ton of new files that have been created. So there's a, where would it be? There's an LMP file, which is my LAMMPS executable. There's the liblamps.so.0, which is my LAMMPS shared file, and a ton of other files. And then the final step is, remember when I said earlier that I need to change my prefix, and I changed my prefix to directories up LAMMPS install. This is just a nice final touch to make it easier to find all of your import files and the ones you shouldn't delete. You can do make install and move everything that's been built already into the directory you specified in your prefix path. That's how you build LAMMPS. It's, I mean, in my opinion, it's super simple. And yeah, go up to directories. There's a directory called LAMMPS install, and in there you'll find the LAMMPS bin, which has my executable, the LAMMPS library, lib64. This is a 64-bit, which has the LAMMPS shared library, and then if you look in the lib, you've got the 3.8 side packages so that you can run through Python. That's building LAMMPS. I thought it's one of those small things of, if you've never done it before, it's important to know how it's done. And in most cases, like, it's always important to understand, especially on HPC systems. Like we the Archer 2 team, always make sure to keep a record of how we build our various codes. And you can find like all of the build instructions for all of the codes on Archer 2 that we maintain. You can all in this link in this page. But it's sort of important as a user when you use the module load LAMMPS command to understand what packages are available and maybe also how things were built, just so that you're aware of what, there's always things that you're going to include and things you're going to keep out, and it's important to know which are included, which are kept out, and why. And sometimes if there's some things that we've not included that you're interested in, then it's important to also know how you can build it yourself. Okay, so yep, let's share the course material again. There we go. So we've kind of gone through this. We've kind of described what all of the things were. And then once it's done, as I've mentioned, you've got you've got your LAMMPS bin, your lib64, your lib Python side packages. You need to add those. If you want to just use them without having to link directly to those paths, you'll need to add them to your path, your LD library path, and your Python path variables, which is kind of what we've been doing throughout this course. As an interesting aside, I've mentioned that you can load modules, and there's a LAMMPS module on Archer 2. All that a module does effectively is load the prerequisite modules and add write bits to your paths. So it's a different way of doing the same thing, really. It's a bit neater, tidier, and there's a bit more black boxy, which but it's also still important, I feel, to know what the black box is doing. Okay, so running LAMMPS through Python. Running LAMMPS through Python is super simple. Provided that you've got your shared library in your library path, so your LD library path, and your Python side packages in your Python path, then all you need to do is run from LAMMPS import LAMMPS, define a function, and in your main function, run the lmp equals LAMMPS brackets command, which starts off LAMMPS. And you can run an input file by running lmp.file and then the name of the file. So, okay, why are we spending some time, at this point, what I've just said is, well, you can run LAMMPS through Python by doing exactly the same things as you do outside of Python. Okay, maybe with some extra fluffy complications. But you could do all of this, like if you were going to run the in.lj file, which we'll be using, you could just do that using the LAMMPS executable. Why are we bothering with Python? And there's a couple of answers to this one. The first one is, quite frankly, you never need to use Python. However, Python has a number of functionalities, and it's a code that's very accessible that many people use. So part of the reason that we're spending some time talking about Python is that we're aware that there's probably some people on this call who are interested in running LAMMPS through Python, who are more familiar with Python scripting than they are with LAMMPS scripting. And sometimes LAMMPS scripting can be a bit clunky, and it's possible to take that clunkiness through Python and do the clunky bits in Python and the LAMMPSy bit in LAMMPS to get it. So sometimes it can be nicer, but overall, like you never need to use Python to run LAMMPS. And sometimes when things go wrong, especially running LAMMPS through Python can make things more complicated. If something goes wrong, it's difficult sometimes to tell, is it going wrong because of LAMMPS? Is it going wrong because of Python? Is it going wrong because of the two communicating somewhere? But I'm aware that this is something that's on demand, so let's talk a bit about it. So in this, when you run this in Python, Python will use the shared LAMMPS library to run this, and under the hood, LAMMPS is doing exactly the same thing as it would if you ran the LAMMPS executable. And so the jobs actually end up running in comparative times. One of the main advantages of running LAMMPS through Python, as I described, is that you're able to make use of, I've not described this one, you're able to make use of Python's dynamic programming, which is that you can kind of like set up your LAMMPS variable within Python, or your LAMMPS fixes and computes and things like that, and then LAMMPS within Python for a bit of time, and then change a couple of things and run it again, and you sort of get that nice, lovely flow of outputs, which Python does quite well. And also the other one is the one I did mention before. Well, LAMMPS does offer a large amount of options, and you're able to use like variables to define variables. You can use jump commands to do loops. You can use if statements. You can code in LAMMPS if you want, but it's not nice. But I guess the best example of this we'll see in a sec when we do this exercise is well, actually I'll swap to. Sorry, we'll see an example of the difference between using LAMMPS versus using Python to code some things in a sec. As before, for this course, you can get the exercises by using the SVN checkout command. I will put the link to the course note here. And this will happen in exercise 4. And I think for the rest of this, I will be in my turn. Okay, let me clear that. So I go, that's right. I go exercises in 4. This is the Python exercise, and again, you've got 3 files in here. You've got the in.lj file, which is exactly the same as the previous one. I'm actually going to drop this to 2020 so that it's a bit faster, because I found 40 was a bit too long for my taste. Sorry, in.lj is exactly the same in.lj as we used in the previous reruns example. I guess the only difference is it's running for 100,000, so there's no equilibration and then a run, and I'm putting a bit more information. Yeah. The next we have is the LAMMPS .py is quite simply Python script to run LAMMPS. And I've tried to make it a bit fancy to explain how things are run with some interesting things. But so the first thing here from MPI for Pi import MPI, that's making sure that that's to ensure that we're running this across multiple processors. Python by itself is not a parallelized programming language, but there is a parallel library for it, which is the MPI for Pi library, and this is just to ensure that we're using that parallel library for these runs. Next is from LAMMPS import LAMMPS. As I said before, that's the bit you need in order to make sure that the LAMMPS library, the shared liblamp.so.0 is loaded up in Python. And then our function, we've got LMP equals LAMMPS, starts off LAMMPS. We'll be reading the in.lj library. And so we're running that simulation as it's defined in the in.lj file. And then what we'll be doing is we will be doing a series of 5 simulations. And for each simulation, we will be increasing the size of the atoms in the system. And the first command here, LMP command, what that does is that tells Python this is a LAMMPS command. So Python knows whatever comes next is a LAMMPS command, and we'll interpret it as such. The command needs to be in quotes, but you can put Python variables in there. So I'm using the %i to tell Python, oh, and I'm going to put an integer variable into this, and the integer variable is just the dummy variable I in this case. Then this bit is Python. It's simply saying the cutoff is going to be 1.1 plus 0.1 I. So what I'm going to do is I'm essentially increasing the size of my particles from 1 sigma to 1.1 sigma in the first run, then 1.2, then 1.3, then 1.4, then 1.5, then 1.6. So the system is going to slowly expand. The particles within my system are slowly going to expand. I run the LP command to increase that. So the pair coefficients is changed so that all atoms, star means all atoms, all the pair style for all atoms, all combinations of atoms, have %f is my cutoff, which means my new sigma, and then 1.0 for the epsilon. And then I'm going to run this for 100,000 time steps. MPI finalize is just to make sure that the MPI library is closed, and then I run Python script. So as you can see, it's quite easy to run, and already you can see some of the functionalities. Like it's so much easier to write a for I in range 5 than it is to set up a series of jump commands. And both do exactly the same thing. Is sub.slurm file, which looks exactly the same as the ones before. I'm running on 128 cores with just MPI ranks, no OpenMP ranks. And then rather than running LMP minus I in in.lj, I'm running Python lamps.j.py. So if I submit, cool, and then watch SQ-u. There we go. That's just running in the background, and hopefully this should take about, I don't know, maybe a minute to run. So super simple to use, and super simple to kind of link. And so far we're only very much skimming the top here, because in 45 minutes we're not going to be able to delve too deeply into this, but we can still do a lot. If you're following along, by the way, please feel free to run that same simulation to get an idea of it, like what it does. There. It's running. If I run ls minus lrt, you'll notice as it's producing the log files. Part of the reason it's producing the log files is because it's called lamps.lj.py. If lamps.lj.py, lamps_lj.py, I've told Python to run this command, do a new file. So every time it starts a new loop, it starts a new log file. So we know the log file log.lamps is just the initial run of in.lj. Then log.0 is with the first cutoff, and then log.1 is with the second cutoff. With the first atom size parameter, then the second size atom size parameter, etc., etc. And once it's done, I mean, I'm sure you believe me, but I can. Log lamps just runs everything that's defined in the in.lj file, and then it says, okay, we've changed some things, and if I do log.pro, it tells you we've reset the pair coefficients. They're now rather than being 1.0, 1.0, they're 1.1, 1.0, as expected. And if you get, I don't know, random one, log.3 uses 1.4, 1.0. So kind of what you'd expect. Cool. Let me stop sharing real quick and share the course material. So I'm only really skimming the top of what you can do with running lamps through Python. But actually, if you go in the lamps manual, it sort of gives you a ton of it gives you a ton of different things you can do. So it really defines the lamps class API and gives you all the properties you can use. So for instance, you've got things like get OS bot info, so you can find out about the information, MPI comms as well, so you can really define those. But then there's other like get n atoms. You can find out, there's an actual Python command for getting the number of atoms. You can extract the box sizes and dimensions quite easily. You can reset the box and dimensions. Get some remote styles, extract some data types, extract information about atoms. There's a ton of things. Like if you wanted to go down this rabbit hole, there are so many things you can explore and twiddle with. And definitely, if you're more familiar or even more comfortable running things in Python than you are running things in LAMMPS, from what I've seen, because as soon as you set up the run, everything's run in LAMMPS effectively, rather than using than in Python. They're equally to one another. The important thing to bear in mind, though, is you absolutely, absolutely, absolutely must link to your shared library and to the site packages. So that's me on Python. I guess as a small exercise before we finish off today, I would suggest that you try altering the lamps_lj.py script and see, instead of running a set of simulations that increase the radius of the particles, could you instead try to run a simulation where every time step you increase the temperature of the simulation? Sorry, not every time step, but you sort of like run the initial simulation and then run it again, but with a temperature of 25K higher, and then 25K higher, and then 25K higher, Kelvin. And if you have any questions about running lamps through Python, please do let me know. So one thing I've noticed is I'm using reduced units in this, so increasing things by 25K is going to go, well, not really possible. So instead, if you increase it by 0.25 or even 0.25, that should give the effect. How I went about this. What did I do? So I set up two variables. The first one, temp1, is the temperature at the start of the simulation. Temp2 is the temperature at the end of the simulation. And temp1 is always 0.25 less than temp2. And then the commands I use are lmp.command unfix1. You'll have needed to, the first step you'll have needed to do is go into the in.lj, notice that the time integration in this simulation is being run by the NVT fix. So if you want to change the temperature, you'll need to unfix this and reset it, which is what I did. So I unfixed it and then reset it to a new thing which uses temp1 and temp2, and then I'd run it for 100,000 time steps. And if you run that, you get two. Sort of tells you 4.2, it's running with fix1 all NBT, temp starts at 0.5, which it does, and ends at 1.75. And hopefully, if we go all the way to the bottom of the simulation, it ends on close enough to 1.5. There's always going to be fluctuations in this case, because we're doing this over such a short time. Yeah, so that's a very brief introduction to running lamps through Python. As I said, the main reason I wanted to add this is it's one of those functionalities that is super useful a lot of people. One thing you may have noticed is I didn't mention PyLamps at any point. That is, from my understanding, PyLamps is maybe like it's got a certain nice functions, but actually it's a bit more gimmicky than anything. So if you're going to be running Python, we strongly recommend that you sort of use this less visual method of running. And yeah, so the key points from this section are that compiling lamps with CMake is easy and quick on Archer 2, and it will probably be likewise on your systems. You might need to, actually, you shouldn't even need to specify the libraries. That should be able to find and pick them up by itself. Running lamps through Python can have certain advantages. However, if anything goes wrong, it can be tricky to find out exactly where things have gone wrong. Cool. So with that, that takes us to the conclusion of our course. And in this section, what we want to do is to offer, well, to do two things. The first one is the next steps. You've been on this, what next? And the second one as well is we want to allow you some time to ask any questions that maybe we didn't have time to answer, maybe we didn't include in the course that might interest you. And Stephen and I are happy to answer any of the questions that you might have. Okay, so well, what's next with respect to lamps? We've tried to show you a number of techniques which we think are A, useful, and B, not necessarily thought of immediately by people who are new to lamps. So sort of advanced techniques that really can make your simulations go from, well, I just use a black box to, well, I understand what's going on under the hood, how to tweak it to make sure that I get exactly what I want out of it. There's a number of other topics and other things that we would have wanted to mention but didn't have time to. One of them is particularly is how to use hybrid pair styles and how to not misuse them, because they are something that are super useful but very, very easy to misuse. So we've really tried to emphasize more on, first of all, how do you get the best performance out of your software package? And let me stress it again, make sure to run test systems before you run your full-on massive production run, because you can get a ton of information from that. And then we also spent some time talking about replica exchange, which is an advanced method, and also running LAMMPS through Python. There's a ton more that LAMMPS has to offer, and all of like everything we've taught today, except for Stephen's Python script in the replica exchange. Everything we've taught is from the LAMMPS manual. It's not word for word copied, but all of the ideas and principles are there. So if you want to learn more about a functionality that you are aware of, the LAMMPS manual is the best place to start. If you want to find out a bit more about what other functionalities LAMMPS offers, I would suggest two places. The first one is the how-to section of the LAMMPS manual, and let me click on that because it's really good. Which gives you a number of guides on how to run various things. So you can run multi-replica simulations is one of the sections that come up following our idea for doing this, and it gives it in a couple of different ways. It's less in depth than what Stephen did by miles, but there's still a lot of information there. How to run with barostats, how to run with so considering simulations that fluctuate under pressure, how to calculate your constants, all that sort of thing. There's ton to do there. How to add tip 3p or tip 4p water. Yeah, lots of useful things. The next great thing, place to learn about functionalities you might not be aware of, are the LAMMPS exercises scripts. There's when you download LAMMPS, one of the things you get is a like with the LAMMPS, my LAMMPS directory, there's a folder called, I think it's called examples or tutorials, something like that. And in that, there are a ton of LAMMPS scripts, and each one of them sort of like teaches you something else, something different. So for instance, if you wanted to run dipole systems, systems with a oriented charge or a dipole, you can look at the dipole example and see what it does, and then run it to get exactly what the commands are. If you want to, I don't know, the micelle one is a nice one that shows you self-assembly of a small lipid-like molecule. There's loads of things in here that you can run, and you can even look at input scripts to get an idea of exactly what LAMMPS is doing or what the script is making LAMMPS do, and you can sort of find the bit you're interested in and copy it across into your script and play around with it to make it work. And that's usually a really good source of inspiration. And then finally, if you have any questions, if you've got anything that's not working, or if you want to find out if something exists that you're really struggling to find, there's the LAMMPS mailing list. And in the mailing list, you can post questions, or you can also, all of the questions are recorded. Hopefully there we go. So yeah, for instance, there's a LAMMPS release from 7 days ago. And there's just a ton of questions, and it's answered. It's questions from people from the LAMMPS community, from users of LAMMPS, and it's answered by a mix of LAMMPS users and also LAMMPS developers. There are loads of them already. So if you have a question, the first thing I do is look through the mailing list records before you post a question. And if because there's a lot of questions that get repeated, and the LAMMPS developers tend to be less happy about always answering the same questions. Regarding Archer 2, by attending this course, you've been given access to, or because you've attended this course, you've been given access to Archer 2. and your account in the TA058 budget will remain active for I think it's 3 months. It might be 2. And there is some credits, some budget associated with your account as well. The idea of this is twofold. The first one is it's to let you explore using Archer 2, so that you try out maybe your LAMMPS simulations, maybe if you didn't have time to complete some of the exercises, that sort of thing. It gives you access to Archer 2 so that you can keep well, you can make sure that you've understood and done all of the practicals in this session as well. It's there for you to use. You're welcome to use it. You are by no means obligated to use it. It's just like, I think it's a nice, and it's, you know, I would strongly recommend making use of it. If you have any questions about Archer 2 specifically, the first place to go to is the Archer 2 manual. The Archer manual has a ton of information, and that information can range from like best practices and guides. So how do I connect to Archer? How do I transfer data onto Archer? How do I handle input-output? How do I use Python? That sort of thing. And go all the way to like super complicated things like if you go to data analysis tools, or even, I don't know, a good one. Like some of these like debugging profiling, for instance, are more advanced programming techniques, but there's still information on there on how to do it on Archer 2, so that's quite a useful place to go to. If you can't find an answer to your question within the documentations, then the next port of call is there is a service desk which you can contact emailing support@archer2.ac.uk. And if you ask a question about Archer 2, you'll usually get an answer within, within minutes, frankly. It can be a bit long, difficult question, but we try to answer those quickly. And Will and I are both part of that support team, so hey, maybe you'll fall on someone you know. If you're asking a question specifically about this course, please mention in the email subject that it's to do with this course, and that way it's definitely going to come to me, and hopefully I can answer it. And then finally, this is run under the Archer 2 training. You can find more Archer 2 training on the training page, and that tells you lots of information, but it does mainly tell you, or of interest is, it tells you the courses that are coming up, including the course we're on today. But then next week we've got one on how to use the HPE Cray Archer 2 supercomputer efficiently by Cray, by the people who bring the machine, who make sure that the machine works. There's an introduction to Archer 2 if you're a software developer. There's an introduction to GROMACS course that I'm on, which is happening. I think I'm only doing one section on that, but it'll be run by one of my colleagues who's really, really good at GROMACS. And I think Stephen's also doing parts of it. Stephen will tell me if he's not. Archer 2 for data scientists, that sort of thing. So there's a ton of useful courses. And even better yet is if you go in the course repository, every past course from the Archer 2 training are available. And for most courses, if you click on them, like past courses, if you click on them, you will find that there's course materials, and then there's also a link to the YouTube video for that course. So you can learn a ton of things by just going through the Archer 2 training, which is the next point. And so with that, I'd like to take a moment to, well, first of all, say thank you to Stephen for taking the time to talk about Replica Exchange, because I knew nothing about it until today. I'd like to thank also William for taking the time to help out, and also thank all of you for attending this course, and I hope that you enjoyed it. As I said, I'll be sticking around for a bit. If anyone has any questions they want to ask, I'm more than happy to answer them now. And yeah, I'll probably stay here at about 5-ish. Thanks, everyone.